Hello great aspirants. Welcome to part 2 of Electromagnetic Theory series. Question number 16. Two charges Q and 2Q are placed along the x-axis in front of a grounded infinite conducting plane as shown in the figure. They are located respectively at a distance of 0.5 meter and 1.5 meter from the plane. The force acting on charge Q is. Now this is a conducting plate, infinite conducting plate, so we will use method of image charges. So this is the case. This point here we have Q. So at the same distance we will have minus Q. Here we have 2Q. So here we will have minus of 2Q. This is at distance 0.5. This is also at distance 0.5. And this distance is also given. So this is 1.5 and this will also be then 1.5. And we have to find force acting on charge Q. So this is charge Q. So we have total 3 charges, minus 2Q, minus 4Q and 2Q. So we will consider each case. So this is minus Q charge and this is Q charge. So they both will be attracted towards each other. So force due to this will be towards it. So it will attract it. So if I am considering force on this, so this will be towards this. This will also have force in this direction. And this will try to repel it. So force of repulsion, this will also be in the same direction. So we can add this because all these forces are in same direction. So force is equal to, first one is K, Q1, Q2 upon R square. So this, let us consider this pair. So this we have Q into Q upon distance. So this is 0.5 plus 0.5, so 1 square. Plus second is K into 2Q into Q. And this distance will be, this is 1.5 plus this 0.5, so this is 2, so 2 square, plus next is this one, so we have Q and into 2Q upon, this is 1.5 minus 0.5, so 1 square, so this is equal to KQ square by 1, so that is KQ square only, plus here we have K 2KQ square upon 2 square, so this will be by 2, plus this will be 2 into K into Q square. So this will be 3 plus half, so that is 7 by 2 into KQ square by this, that only 3 by 2 KQ square. So this we can write as 7 by 2 into Q square upon K is 4 pi epsilon naught. So we have option A here. Next question. A uniform surface current is flowing in the positive y direction over an infinite shape lying in the xy plane. So consider an xy plane. So this axis is x and this is y and this will be then z. And there is this sheet in the xy plane. The direction of the magnetic field is. So here we have to find direction of magnetic field. Current is going in y direction. So in the region z greater than 0, we can consider an Amperean loop. So this loop is like this and current will flow like this. Now curl your finger in the direction of this loop and thumb will point towards magnetic field. So here magnetic field will be in this direction. So for z greater than 0, this B will be, it will be along, magnetic field will be along I cap direction. And then we can consider this also. So current is going in this direction, so loop will complete like this. So here the direction of magnetic field, it will be inwards. So for z less than 0, this will be in minus I cap direction. So here for z greater than 0, it will be plus I, and for z less than 0, it will be minus I. So option A is correct. Question number 18. A magnetic dipole of dipole moment m bar is placed in a non-uniform magnetic field b bar. If the position vector of the dipole is r bar, the torque acting on the dipole about the origin is. This is direct formula. This is equal to m bar cross b bar plus r bar cross del of m bar dot b bar. For non-uniform magnetic field, this is expression for torque. So option D is correct. Next question. Which of the following expressions for a vector potential A bar does not represent uniform magnetic field of magnitude B naught along the z direction? So we know V bar is equal to del cross A So for each case we have to calculate this. So we'll do this one by one. So del cross of A bar is equal to I cap, then we have J cap, K cap, dou by dou x, dou by dou y, and dou by dou z. For the first case, this is 0, B naught x and 0. So this will be equal to 0, first two terms will be 0 and last term will be K cap into this we have B naught. So this will be B naught into Z cap. And B bar is this B naught into Z cap. So this is following. So option A is correct. Then second one, del cross A, this will be equal to same thing. Now first is minus of B naught into Y into 0 into 0. So this will be equal to again K cap into dou by dou x, this will be 0 and this will be minus of minus B naught. So this will be B naught into Z cap. So this is also correct. Now for the third case, del cross of A, this will be I cap, J cap, K cap, dou by dou x, dou by dou y and dou by dou z. So this is here B naught x by 2 and here we have B naught y by 2 into 0. So this will be K cap into this will be dou by dou x of this. So this will be 0 and this will be 0. So this is 0. So it is not representing uniform magnetic field. So option C is correct. And you can check for option D as well. It comes out to be, this will be B naught by 2 and minus of minus B naught by 2 into we will have Z cap. So this will be B naught into Z cap. So D is also correct. So here option C is correct. Next question. A spherical conductor of radius A is placed in a uniform electric field E bar is equal to E naught K cap. The potential at point P for R greater than A is given by this phi, some constant minus E naught R cos theta plus E naught A cube upon R square into cos theta, where R is the distance of P from the center of the sphere and theta is the angle OP makes with the Z axis. The charge density on the sphere at theta is equal to 30 degrees. Now this is a spherical conductor and here we can use boundary conditions. So when x is less than r, so inside this electric field is 0. So I can write this perpendicular component of electric field. So we can write E above this surface upon E below the surface. This will be equal to sigma by epsilon naught. So this above, this can be written as, now E is equal to minus dou V by dou R. So this will be minus dou V by dou R minus 0 because electric field inside is 0. This is equal to sigma by epsilon naught. So from here we can write this charge density. This will be equal to minus of epsilon into dou V by dou R. So this will be equal to minus of epsilon and this potential is given to us and we have to find dou V by dou R. So this will be, first term is 0, then we have minus of E naught into cos theta, then this will be A naught, E naught, A raised to Q, then R raised to 2. So this will be minus of 2 upon R cube into cos theta. And we have to find value of this at theta is equal to 30 degree. So this will be minus of epsilon naught into minus of E naught into cos of 30 degree. And cos of 30 degree is root 3 by 2 plus 2 into E naught into A cube upon R cube, and cos 30 is root 3 by 2. And we are calculating it on the sphere. So on the sphere R is equal to A. So here I can write R is equal to A. So this A cube and A cube will cancel and then we'll get sigma is equal to this minus into plus sign. So this will be epsilon naught E naught into root 3 by 2 plus this will be epsilon naught minus sign, it will be there, minus of epsilon naught E naught into this will cancel out and this will be root 3 by 2. So this is minus, and this will be, again this is also minus here, this will be plus here. So root 3 by 2 we can take common, and here we have 2 also we have here. So this will be 3 into epsilon naught E naught into root 3 by 2. So this will be 3 root 3 epsilon naught E naught by 2. So option A is correct. Next question. A plane electromagnetic wave has the magnetic field given by B bar is equal to B naught sine x plus y k by root 2 plus omega t k cap, where k is the wave number and I cap, j cap, k cap are the Cartesian unit vectors in x, y and z direction respectively. The electric field E bar corresponding to the above wave is. So we have to calculate k bar here. So k bar is equal to, now here it is given, this is sine of x plus y k by root 2. So from here we can write down value of k bar. So this is k only. So this is equal to, this is this part, this particular portion is k bar dot r bar. So that will be k bar dot of x cap plus y cap plus z cap. So this x term is there. So that means kx will be k by root 2 and ky will be k by root 2. And for this wave, if we are considering it is going in forward direction, so this k will be, this will be omega t minus of kx. So this k bar can be written as minus of k into, we have I cap plus j cap upon root 2. So this will be k bar. Now E bar is equal to, we have minus of c by k into k bar cross B bar. So this will be equal to minus of c by k. K bar is minus of k into I cap plus j cap by root 2 cross B bar. B bar is B naught into sine of x plus y into k by root 2 plus omega t into k cap. So this will be equal to, this k and k will cancel out, minus minus it will become plus. So this will be c by root 2 into, we have b naught into sine and this whole term into, we have here I cap cross k cap. Now I cap cross k cap, it will be j cap. So this will be j cap, and second term is j cap cross I cap, j cap cross k cap. So that will be plus of I cap here. Here we have minus sign, so this will be minus here because we are considering I cross k. If it is k cross I, then it will be j cap. I cross k is minus of j cap. So this will be minus of j cap plus I cap. So this will be the answer. So minus j cap plus I cap. So option A is correct. Or you can go through the options as well. That means this E bar, direction of E bar cross direction of B bar, this should be equal to k bar. Like this should be in the direction of k cap bar. Now here k cap is given, k cap is in minus I cap minus j cap direction. So from there also you can calculate. Or you can go like this, you can consider this B cap and then multiply by k cap. So that will also give you direction of E bar. So we will use this here. This method also you can use. So this k cap cross I cap, consider this. First we have this I cap minus of j cap. If we consider this to be E bar, then B cap is B bar is in k cap direction. So I cross k, that will be minus of j cap, and minus of j k, that will be minus of I cap. So yes, it is satisfying this. So option A is correct. Similarly, you can check for other options. So for option B, we have I cap plus j cap. So this will be E bar, direction of E bar cross k cap. So I cross k, that will be minus j, and j cross k, that will be plus I. So this is not following. For option C, we have I cap cross k cap. This will be minus of z. It is not correct. Then j cap cross k cap. This will be r. This is also not correct. So instead of solving, you can quickly go through the options as well. Next question. A plane electromagnetic wave, same question is there, and question is the average Poynting vector is given by. Now Poynting vector S is equal to 1 upon mu naught 1 upon mu naught into E bar cross B bar. So if you want to find average value of this, so that comes out to be 1 upon 2 mu naught into E naught into B naught. This is in terms of B naught here. So I can write E naught is equal to C into B naught. So this will be C into B naught square upon 2 mu naught. Now this will be in the direction of S bar will be in direction of K cap. So this will be in direction of K cap. So this will be C B naught square upon 2 mu naught, and direction of K cap will be minus of I cap plus J cap upon root 2. This we have already calculated from this equation. So here option D is correct. So these were all the questions from GATE 2011 paper. If you like this video, please give it a thumbs up and subscribe to my channel for more videos. Keep learning.